In the last video, we talked about what it means to take a positive number and raise it to the power of a fraction where the fraction is 1 over some integer, a positive integer. So something like 10 to the 1/2 power is the square root of 10, or 100 even to the 1/2 power, whatever positive number to the 1/2 power is the square root of the base. Square root of 100 in this case is 10. 100 to the 1/3 power is the cube root of 100. 100 to the 1/4 power is the fourth root of 100, and so on. Now we're going to extend this. So in general, 100 to the 1 over n power is the nth root of 100. And in fact, if a is any positive number, a to the 1 over n power is defined to be the nth root of a. Now we're going to talk about something like 100 to the 2/3 power, or 3 over 2 power. Well, to define this, we're going to use the properties of exponents as a guide. So what we would like to do is we would like the exponents to work in such a way that if you did 100 to the 1/2 power and then cubed it, the result would be 100 to the 3/2 power, because you want to be able to multiply the exponents together. And that leads us to define 100 to the 3/2 power. It's just going to be the cube root of 100 cubed. And the cube root of 100 is 10 cubed, and 10 cubed is 1,000. So 100 to the 3/2 power will be defined to be 1,000. And something like, let's do 8 to the 2/3 power. Well, how do we make sense of 2/3 power? We could define it to be 8 to the 1/3 power squared. And 8 to the 1/3 power is the cube root of 8. So the cube root of 8 squared, well, the cube root of 8 is 2. 2 squared is 4. So we would define 8 to the 2/3 to be 4. And in general, we define a to the m over n to be a to the 1 over n power. So that's the nth root of a raised to the m power. So the nth root of a raised to the nth power. And this allows us to define fractional exponents for positive fractions.